Dear students, welcome back. In this session, we are going to discuss about direct current for the treatment of patients from the AC main. Okay, we have discussed in previous discussions about the various devices and circuits. So now we are going to use those devices and circuits to produce direct current for the treatment of patients. Here is a circuit or we can say a schematic representation of converting the alternating main current into direct current, and which is finally given to the patients. How it is going to take place, now we will see. So the apparatus for obtaining direct current for the treatment of patients may incorporate either metal rectifier, okay, so here this one is metal rectifier circuit, or a valve circuit we can use. So the metal rectifier is satisfactory for the low voltage whenever low voltage is required, but the valve circuit used when the circuit forms part of a combined treatment unit in which these valves are used for the protection of other currents. Okay, for these two uses, these circuits can be modified. Okay, now first we will see the metal rectifier circuit. We are using metal rectifier circuit for DC from AC main. Okay, so here is the circuit for this thing. So the metal rectifier circuit, the alternating main current is passed through the step-down transformer. So here this is the step-down transformer. From this step-down transformer, the alternating current is passed, and here which reduces the EMF to approximately 110 volts and makes the current earth free at this stage. Okay, and tappings on the primary coil of the transformer enable, so here we can tap enable the apparatus to be used on supplies of different voltages. Okay, so this can be done at the step down transformer stage. Now this secondary coil of this transformer is going to connected to a Westinghouse bridge circuit, that is called as metal rectifier circuit. We have discussed this thing separately, which helps in the rectification of alternating current to the direct current. That to full wave rectification we have discussed this Westinghouse bridge. Okay, so this Westinghouse bridge consists of two pairs of rectifiers. So this circuit is called as metal rectifier circuit. Okay, yes. So what happens at this stage? So here the alternating current which comes from the secondary coil is going to rectified into direct current at this stage. Okay, so the number of in the Westinghouse bridge circuit of metals rectifiers, the number of blades which are present in the rectifiers are used, which is sufficient for 110 volts. Okay, after passing through the rectifier, it becomes unidirectional pulsating current. So what is the type of current which is coming outside from this Westinghouse bridge? It becomes unidirectional and pulsating current. but it is having some variations in the intensity that may not be suitable for the patient. So at this stage, after rectification, the unidirectional pulsating current is going to smoothened. So that one is smoothened, which is suitable for the patients, is done by this smoothing circuit. So the smoothing circuit also we have discussed earlier. Okay, so this smoothing circuit helps. Helps the rectifying current, which is unidirectional, but varies considerably in intensity. Okay, so in order to eliminate these variations and render the current suitable for the application to a patient is mainly done by this smoothing circuit. Okay, and this smoothing circuit, which is consisting of two condensers, and a choke coil, these are connected in series with the output wires. Okay, so the current then passes through the potential divider. So once the current is smoothed, it is then passed to the potential divider. So this potential divider is mainly used for regulating the intensity of the current. Okay, after after potential divider, it has been taken to the patient terminals. Okay, and this circuit also consists of milliampere meter and reverse switch may be included for the use of this reversible switch is to reverse the polarity. Okay, for that purpose, and for recording this how much of current have been supplied to the patient terminal is going to be seen in the milliampere meter and also the direction. Okay, this is the way how the direct current is used to the AC main, used to the patients from the alternating current main. Okay, so another type which can be used, that one is wall circuit. So the same entire sequence is same for the second method also. We are using wall circuit instead of this Westinghouse bridge. So we just remove this part of Westinghouse bridge and we are going to include this wall circuit. Okay, so that too, especially in the wall, mainly we are going to use this diode wall. Diode wall is the only wall which helps in the rectification of alternating current to direct current. So instead of this place, we are using this wall circuit. So the metal rectifiers are replaced by the diode wall with two anode plates. Here you can see two anode plates are used instead of single anode plate. So such kind of wall circuit we are going to use. So the current from the secondary coil of the transformer is taken to the wall here. Okay, and which is transmitted here. The current is going to rectify, and which one here we will have the terminals here. These terminals are directly connected to this smoothing circuit and then the potential divider and reversible switch and to the finally patient terminal. The same sequence is going to be done in this wall circuit also. So here the voltage is halved by this arrangement and the pulsating direct current obtained is smoothened and then to the potential divider and finally it reaches to the patient circuit, which is also consisting of milliampere meter and the reversible switch. So these are the things or these are the two circuits we are using for direct current for the treatment of patients from the alternating main current. And in this session I want to mention some of the steps to be taken for the care of apparatus. How should you care the physiotherapy apparatus? So I want to discuss it here only. So all apparatus should be clean and dry, and these apparatus should be dusted regularly and covered when not in use. And some moisture if is present on the apparatus, which is liable to cause corrosion, and if any part of the circuit is affected, extensive damage may result. So you have to use damp pads, and should never be placed on the apparatus, and the operator's hands should be dry when handling the equipment. Okay, and circuits which incorporate valves. So some of the circuits which are used valves require about 1 minute to warm up after the current has been turned on. Once the circuit has warmed up, the current should be left on if the apparatus is required in a short time, as repeated heating and cooling shortens the life of the filament of a valve. So great care must be taken to leave the controls at zero, and it is advisable to detach the leads from the patient terminals while the apparatus is switched on but not in use. Okay, in order to eliminate the danger of electric shock from inadvertent contact with the electrodes. The physiotherapist cannot repair defects in the circuits of the modern electrical equipment, but should be able to remedy fault, wall plug and lead connections. If when the apparatus is connected to the supply and switched on, the pilot lamp does not light, then the wall plug connections may be at fault. Okay, these are the things the physiotherapist should know. If the pilot lamp, that is main lamp, okay, pilot lamp lights but no current is obtained for the patient, the connection of the leads of the patient terminal should be examined. So these are the things done by the physiotherapist, but the physiotherapist cannot repair the defects in the circuits of the modern electrical equipments. Okay, and a cell battery. The cell battery requires renewal of the cells from time to time, and this can be carried out by the physiotherapist. Inadequate output of current usually indicates that new cells are needed. This one also you should know. So inadequate output of current usually indicates the new cells are needed. The apparatus should be kept in a cool, dry place. Okay, as dampens and warmth shorten the life of the cells. Okay, so these are the things a physiotherapist should keep it in mind, and by this way you have to care of your apparatus. Okay, thank you.